Not just to visit the moon, not just to plant a flag, but to build something permanent, a base, a foothold, a place where humans may one day live for months or even years. And one nation is moving forward with a detailed, step-by-step plan to make that happen. This is not science fiction, it is engineering, robotics, nuclear power, underground tunnels, and long-term strategy. And if everything moves according to schedule, the 2030s could mark the beginning of permanent human presence on the moon. Welcome to Orbit Myth, where we explore the edge of space, future technology, and the bold plans that could redefine humanity. On this channel, we break down complex space missions into clear, powerful stories that help you understand not just what is happening, but why it matters. If you are fascinated by lunar colonies, Mars settlements, and the next chapter of civilization, you are exactly where you need to be. Now let us talk about the plan. Building a base on the moon sounds exciting. It also sounds simple when someone says it quickly. Just send materials, land astronauts, build some habitats, and start living there. But the reality is far more complicated. The moon is not a friendly place. First, there's no atmosphere. That means no air to breathe, but it also means no protection. On Earth, our atmosphere acts like a blanket. It regulates temperature and burns up most incoming space debris before it reaches the ground. On the moon, there's no such shield. When sunlight hits the lunar surface, temperatures can climb above 120 degrees Celsius. When darkness falls, temperatures can drop below -30 degrees Celsius, and in some regions even much lower. And because the moon rotates slowly, one day on the moon lasts about 29 Earth days. That means roughly 14 days of continuous sunlight, followed by 14 days of continuous darkness. Imagine living somewhere where you have 2 weeks of non-stop heat, followed by 2 weeks of freezing cold. No sunrise each morning, no sunset each evening, just extremes. Then there's radiation. On Earth, we are protected by a magnetic field created by movement inside our planet's core. That magnetic field deflects a large portion of harmful solar and cosmic radiation. The moon does not have this protection. Radiation constantly strikes its surface. Long-term exposure to this kind of radiation can damage human cells and increase health risks. So any habitat on the moon must provide serious shielding. And then there are meteorites. When you look at the moon through a telescope, you see craters. Those craters were formed by impacts. Space rocks still collide with the moon regularly. On Earth, most small meteors burn up in our atmosphere. On the moon, there is nothing to slow them down. So now we have a picture. No air, extreme temperatures, high radiation, constant impact risk. And yet, despite all of this, plans are moving forward.
The strategy is not to send people immediately. Instead, the approach is gradual and methodical. Think of it as a 3-stage process. First comes exploration, then construction, then habitation. The first stage focuses on robotic missions. Before humans can live there, machines must scout the terrain, test the soil, analyze resources, and gather data. Over the past few years, multiple robotic landers and rovers have been sent to study different regions of the moon, particularly the South Pole. This area is of special interest because scientists believe it contains frozen water in permanently shadowed craters. Water is critical. It can be used for drinking, growing food, producing oxygen, and even creating rocket fuel by splitting it into hydrogen and oxygen. If water can be harvested locally, it reduces the need to transport everything from Earth. There have also been experiments attempting to grow life on the moon. In one small sealed experiment, seeds were carried to the lunar surface along with nutrients and controlled air. For a short time, a plant sprouted. It became the first new leaf to grow on the moon. But the extreme temperature changes eventually destroyed the experiment. It was a powerful reminder that survival there is fragile. Now let us move to stage 2, construction. There are two main ways to build structures on the moon. The first is simple in theory. Build everything on Earth, launch it into space, and assemble it after landing. But this approach is expensive and risky. Launching heavy materials into space costs enormous amounts of money and requires multiple complex missions. So engineers are focusing on something called in situ resource utilization. That simply means using materials that are already there. The moon is covered in a layer of fine dust and broken rock called regolith. This material can potentially be turned into building blocks. One proposed method involves robotic systems collecting lunar soil, compressing it into molds, and heating it at high temperatures to create solid bricks. These bricks could then be stacked to form protective outer walls, landing pads, and roads. These thick structures would provide insulation against temperature swings and shielding against radiation and small impacts. However, there is a challenge. A rectangular brick building is not ideal for holding internal air pressure. Since the moon has no atmosphere, habitats must be pressurized to support human life. Round shapes are stronger under pressure. That is why propane tanks and submarine hulls are cylindrical. So engineers have explored more advanced designs. One concept involves 3D printing habitats directly on the moon. In this process, lunar soil would be melted and mixed with a binding material, then printed layer by layer into a curved dome-like structure. These designs often use multiple layers with internal support ribs to increase strength. The outer shell blocks radiation, the inner shell maintains pressure, the middle layer provides structural stability. This type of habitat could potentially be taller than traditional buildings, since the moon's gravity is about 1/6 of Earth's. Moving up and down inside a vertical structure would require less effort, and without wind or storms, tall structures face fewer environmental stresses. But all of this requires energy. A lunar base cannot function without a reliable power source. Solar panels are an option, especially during the long daylight period. However, the 14-day night cycle presents a serious problem. Energy storage would need to last 2 full weeks without sunlight. That is why nuclear power is being considered. A small modular nuclear reactor could provide consistent energy regardless of the time of day. Cooling such a reactor on the moon may actually be simpler in some ways. In permanently shadowed craters near the poles, temperatures remain extremely low. A reactor placed in such a location could dissipate heat more efficiently. Now imagine this: robots building structures, nuclear reactors providing energy, landing pads prepared, roads constructed, communication systems installed, all before a single human arrives. This leads us to the third stage: habitation. The long-term vision includes not only surface structures, but underground expansion. The moon contains lava tubes, which are natural tunnels formed by ancient volcanic activity. In some places, parts of these tubes have collapsed, revealing openings that lead into large underground cavities. These caves could provide natural shielding from radiation and meteor impacts. They also offer more stable temperatures compared to the surface. Instead of fighting the harsh environment above, future settlers might move below ground. Before that happens, robotic missions equipped with ground-penetrating radar will map subsurface regions to identify stable lava tubes. Once suitable sites are confirmed, construction could begin inside these natural shelters. Now, let us pause for a moment and think about what this really means. Imagine you are a young engineer today. You are studying robotics, nuclear physics, or aerospace engineering.
In 10 years, you could be part of a team operating machines on another world. In 20 years, you might watch the first permanent lunar crew broadcasting from a base you helped design. This is not just about national pride, it is about technology, resources, and influence in space. Establishing a permanent base could support future missions to Mars. It could serve as a testing ground for life support systems and closed-loop ecosystems. It could even become a hub for scientific research and astronomy. The plan includes multiple landing missions throughout the early 2030s. Each mission would deliver a specific component. One mission might establish the command and communications center. Another might deploy scientific laboratories. Another could focus on resource processing equipment. Over time, these modules would connect into a functional outpost. And eventually, astronauts would arrive, not for a short visit, but for extended stays. Of course, no timeline is guaranteed. Space missions often face delays. Technical challenges can arise. Budgets can shift, but the direction is clear. Now, let me share one more scenario. Picture a future classroom on Earth. A teacher asks students to name the first generation to grow up knowing that humans live on more than one world, and those students realize it is them. That psychological shift matters. For thousands of years, humanity looked at the moon as something distant and unreachable. Now it is becoming a destination. Let us quickly recap. The moon presents extreme environmental challenges. Robots are currently exploring and testing solutions. Construction methods include brickmaking from lunar soil and advanced 3D printed habitats. Nuclear energy may provide long-term power. Underground lava tubes could offer natural protection, and by the 2030s, the first permanent structures could be ready for human crews. The next decade will be critical. And this is only part of a larger global competition. Other nations are also planning their own lunar bases. The question is not whether humans will return to the moon. The question is who will establish the first sustainable foothold. If you found this exploration fascinating, make sure you subscribe to Orbit Myth and join a community that looks beyond headlines and into the future of civilization. Leave a comment and tell me this. Would you volunteer to live on the moon if given the chance? Or would you rather watch from Earth as history unfolds? The next chapter of humanity may not be written on this planet, and when it happens, you will hear about it here.